Why do you believe that thing you believe? No, I'm serious. Think about it. Right now, in your head, you've got an opinion. Maybe it's about politics. Maybe it's about how smart you are. Maybe it's about whether that person really likes you, and you're sure about it. You feel certain. But here's the thing. How do you know you didn't just make it up? How do you know your brain isn't playing a trick on you this very moment, convincing you of something that isn't true? See, I've spent my whole life in physics, and you might think physics is safe. Numbers, equations, hard facts. But I'm going to tell you something that might surprise you. Some of the biggest mistakes in the history of science weren't made by stupid people. They were made by brilliant people. Nobel Prize winners, the best minds in the world. And you know why? Because they wanted something to be true. They believed it so hard that they bent the world to fit their belief. And here's the terrifying part. They didn't know they were doing it. By the end of our time together today, you're going to understand how your own mind works against you. You're going to see the tricks it plays, and if you're lucky, if you really pay attention, you might learn how to catch yourself in the act of fooling yourself, because that's the hardest thing in the world to do. Let me tell you about the first principle, the most important thing I know. Ready? Here it is. You must not fool yourself, and you are the easiest person to fool. I'll say it again because it matters that much. You must not fool yourself, and you are the easiest person to fool, not other people, not conmen or politicians or used car salesmen. You are your own easiest mark, your own best target. Your brain is running a con on you right now, and it's been doing it your whole life. Now, why should that be? Think about it from nature's perspective. Your brain didn't evolve to find the truth. It evolved to keep you alive long enough to have children. That's it. Truth was never the goal. Survival was the goal. And sometimes a little self-deception helps you survive. If you're slightly overconfident, you might take risks that pay off. If you believe you're more attractive than you are, you might approach a mate who turns out to like you. Nature doesn't care if you're accurate. Nature cares if you reproduce. But here's the problem. In science and in trying to understand the world, self-deception is fatal. It destroys everything. If you believe something because you want it to be true, you are not doing science anymore. You're doing something else, something dangerous, something I call cargo cult science. Let me tell you what I mean by that. In the South Seas during the war, there were islands where the natives had never seen modern technology before. Then suddenly, American soldiers showed up. They built airstrips, control towers, and planes started landing with all kinds of wonderful things: food, tools, medicine, cargo. The natives watched this happen, and they thought, well, this is pretty good. We'd like that to keep happening. But then the war ended. The soldiers left. The planes stopped coming. So, what did the natives do? They figured maybe they could make it happen again. They cleared areas to look like runways. They built wooden huts that looked like control towers. They carved headphones out of wood and wore them. They sat in their towers and waved their arms like they'd seen the controllers do. They did everything right. The form was perfect. It looked exactly like it was supposed to look. But the planes didn't land. See, they had the outward appearance of the thing without understanding what made it work. They didn't know about radio signals or navigation or the whole system of logistics that made those planes up. Yeah. They just copied what they could see. And copying what you can see isn't the same as understanding. Now, you might laugh at this. Wooden headphones, that's absurd. But I'm going to tell you something. There are scientists right now at major universities getting grants and publishing papers who are doing the same thing. They have the form of science without the substance. They have statistics and peer review and laboratory equipment. They write papers that look scientific, but the planes don't land. Their results don't replicate. Their theories don't predict anything new. And they don't even know they're doing it wrong. Why? Because they've fooled themselves. They've started believing something and then they've arranged all their work to prove what they already believe. That's not science. That's rationalization dressed up in a lab coat. Let me give you an example. A real one from the history of physics. Robert Millikan was a brilliant man. Won the Nobel Prize. He did an experiment to measure the charge of an electron using tiny drops of oil. Very clever experiment. He watched the drops fall through the air, then turned on an electric field to make them rise, and from that, he could calculate how much charge each drop carried. Beautiful idea. He got an answer, and his answer was wrong. Just a little bit wrong, but wrong. The number he published was too low by about 0.5%. Now, 0.5% doesn't sound like much, but in precision physics, it matters. And the reason he got it wrong was because he used an incorrect value for the viscosity of air. That's not his fault. Nobody knew the right value at the time. But here's the interesting part. Here's what keeps me up at night. After Millikan published his number, other people started measuring the electron's charge. 2 different experiments, different methods, and if you plot all their results over time, something very strange happens. The values creep up little by little. One guy gets a number a bit higher than Millikan's, the next guy gets a number a bit higher than that. And they keep creeping up slowly over years until they finally settle on the correct value, which is noticeably higher than what Millikan measured. Now wait, think about this. Why didn't someone just immediately get the right answer? Why did it take years for the numbers to drift up? What was happening? I'll tell you what was happening. Those scientists were fooling themselves. They'd measure their old drops, do their calculations, and get a number. And if the number was close to Millikan's, they'd say, good, that makes sense, and they'd publish it. But if their number was way higher than Millikan's, they'd say, Echem, that's suspicious. Maybe I did something wrong. Let me check my equipment. Let me look for errors. And they'd find reasons to throw out the high numbers. They weren't cheating. They weren't lying. They genuinely believed they were being careful scientists. But they had a number in their head. Millikan's number. And anything that disagreed with it too much seemed like a mistake. So, they eliminated the data that would have given them right answer. This pattern has a name now. Scientists call it anchoring. Once you have a number in your head, all your subsequent judgments get pulled toward that number. It's like a gravitational field for your thoughts, even when you're trying to be objective, even when you're doing your best work. That anchor is bending your thinking, and the funny thing is Millikan himself might have done something similar. When you look at his laboratory notebooks, there are comments in the margins, little notes saying things like publish next to some measurements and something wrong next to others. Now, maybe he had good scientific reasons for those judgments. Maybe some of those drops really were problematic. But maybe, just maybe, he was unconsciously selecting the data that gave him a cleaner result. The data that made his answer look more certain than it really was. We can't read his mind. We don't know for sure, but this is the danger. This is what self-deception looks like in practice, not villains twirling their mustaches and deliberately faking data. Just ordinary people, good people, careful people who subtly tilt the playing field without even realizing they're doing it. This is the hardest thing about fooling yourself. You don't know you're doing it. You feel like you're being careful. you feel like you're being scientific. But you've already decided what the answer should be, and you're unconsciously steering toward it. Now, let me give you another example from a completely different field. Psychology. This one really gets me worked up. There have been many experiments running rats through mazes. All kinds of mazes, for decades. People have been studying how rats learn, and in 1937, a man named Young did something very interesting. He had a car with doors along both sides. Rats came in through one side. Food was on the other side. And he wanted to train the rats to always go to the third door down from where they started. Simple enough, right? Teach a rat to count to 3. But Young found something strange. The rats kept going to the same door every time, even when he changed things round. They weren't counting. They weren't learning what he thought they were learning. So he started asking, how do they know which door is which? He painted all the doors exactly the same. Still they knew. He changed the smells with chemicals. Still they knew. He covered the corridor so they couldn't see the lights in the room. Still they knew. Finally, he discovered that they were listening to the sound the floor made when they ran over it. Different. Parts of the corridor sounded different under their feet. He had to put the whole thing on sand to eliminate that cue, and then at last, the rats had to actually learn the task. They couldn't cheat anymore. Now, this is a beautiful piece of science. This is how you do an experiment. You systematically eliminate every possible alternative explanation until you've actually isolated what you're trying to study. Young discovered all the things you have to do to discover something about rats. And do you know what happened after that? I looked into it. The next experiment that was published didn't mention Young's work. The one after that didn't mention it either. Nobody used his methods. They just went right on running rats in the same old way, ignoring all the things that could contaminate their results. And Young's papers faded into obscurity. Why? Because he didn't discover anything about rats. He discovered how to discover things about rats. And that's not interesting to people who've already decided they know how to do their experiments. That's not interesting to people who've already fooled themselves into thinking their methods are good. Enough. This is cargo called science. It has the form of science, experiments with rats, published papers, statistics, peer review, all the right elements. But something essential is missing. The planes don't land. And you know what's tragic? It's not just psychology. It happens everywhere. Education, research, nutritional studies, economics, sociology, any field where the phenomena are complex, where there are many variables, where it's hard to do controlled experiments. Those are the fields where cargo called science thrives. I remember talking to someone about educational research once. They were very excited about some new teaching method that had been proven to work. So I asked a few questions. How many students were in the study? How were they assigned to the different groups? Was it random or did teachers choose? How did they measure learning? Did they account for the fact that kids with motivated parents might do better regardless of teaching method? And you know what I found? The answers to these questions were either vague or missing. The study had the trappings of scientific research, numbers and graphs and p-values, but when you looked closely, the experimental design was full of holes. There were a dozen ways the results could be explained by factors other than the teaching method. This is why I get worried when someone tells me that studies prove something in these comics fields. Not because the researchers are dishonest. Most of them are doing their best. But because the temptation to fool yourself is so strong and the opportunities to do so are so many. When you're studying something as messy as human behavior, you can almost always find a way to see what you want to see. So what is that missing thing? What makes real science different from the cargo cult version? I'll tell you. It's a kind of integrity, a principle of scientific thought that corresponds to utter honesty. It's not just about not lying. Advertising isn't lying exactly, but it's not science either. When someone tells you their cooking oil doesn't soak through food, they're telling you the truth. But they're leaving out the fact that no cooking oil soaks through food at normal temperatures. They're creating an implication that isn't there. Scientific integrity is different. It means you report everything that might make your results invalid. Not just the things that support your conclusion, everything. The stuff that might be wrong. The alternative explanations you can think of. The experiments you tried that didn't work. You snorts have to bend over backwards to give people the information they need to prove you wrong. I'll give you an example of what this looks like. In practice, suppose I do an experiment, and I get a result that supports my theory. A cargo cult scientist would write up the paper and say, "Look, my theory is correct," but a real scientist would do something different. A real scientist would write in the paper, "Here's my result, but there are several things that might make it unreliable. First, my equipment might have had this particular problem. Here's how I checked for it, but I couldn't completely rule it out. Second, there might be this confounding variable that I couldn't control for. Third, my sample size was limited. So the statistical significance could be weaker than it appears. Fourth, here are some alternative explanations that are also consistent with my data. I've tried to rule them out, but here are the ones I couldn't eliminate completely." You see how different that is? The real scientist is actively trying to undermine their own work. They're giving you the weapons to attack them. They're saying, "If I'm wrong, here's how you could find out." That's incredibly hard to do. Your whole career might depend on this result. Your funding, your reputation. And you're supposed to sit there and help people see the flaws in your work. Every fiber of your being resists this. Your brain screams at you, "Don't do it. You'll look weak. You'll lose the argument." But that's exactly why it matters, that resistance. That reluctance to help people prove you wrong. That's where self-deception lies. That's the enemy you're fighting. Think about that for a second. You spend months or years working on something. You think you've discovered something important, and then you have to spend just as much effort trying to tear it down. You have to actively look for ways your result might be wrong. That's a very hard thing to do. Your ego is invested. Your career is invested. And your brain, your own brain that's been fooling you this whole time, is going to resist. It's going to say, "Come on, you know you're right. Don't be so hard on yourself." But that voice is the enemy. That voice is cargo cult thinking. Real science means fighting against your own mind. Let me explain this a different way. Suppose I claim that I can teach a dog to do arithmetic. You're skeptical, but I invite you to my house to see for yourself. I write 2 + 3 on a piece of paper and show it to the dog. The dog barks 5 times. Amazing. I do it again with different numbers. Every time the dog barks the right answer. Now, a cargo cult scientist might be convinced. Look at the results. The dog gets the right answer. What more do you want? But a real scientist would start asking uncomfortable questions. Can someone else rate the problems? Does the dog still get them right if you're not in the room? What if someone the dog has never met runs the experiment? Maybe the dog isn't reading the numbers at all. Maybe he's picking up cues from you. Maybe you're unconsciously nodding or breathing differently when he reaches the right number. This is what really happened with a famous horse in Germany named Clever Hans. The horse seemed to do arithmetic by tapping his hoof the right number of times. For years, people were amazed. Scientists examined him and declared the phenomenon genuine. But eventually, someone thought to test the horse when the questioner didn't know the answer, when the questioner was hidden behind a screen, when the horse couldn't see anyone who knew the answer. And guess what? The horse couldn't do it anymore. He'd been reading tiny unconscious cues from the people round him. The people who believed in clever hunts weren't stupid. They were fooling themselves. They wanted the horse to be magical. So they didn't think to test the one thing that mattered. Can he do it when he can't see you? This is what I mean when I talk about being the easiest person to fool. The clever hands investigators thought they were being rigorous. They examined the horse carefully. They looked for a fraud. But they didn't think to ask the right question because they didn't really want to know the answer. They wanted the magic to be real. Now, wait, you might say. I'm not a scientist. Why should I care about all this? This is all about experiments and laboratories. What does this have to do with regular life? And the answer is everything. Because you're running experiments all the time. You're testing ideas about the world constantly. Should I trust this person? Is this relationship working? Am I good at my job? Am I making the right choices? Every day you're gathering evidence and drawing conclusions. And every day your brain is lying to you about what that evidence means. Let me give you some everyday examples. You buy a new car. It costs a lot of money. And suddenly everywhere you look, you see other people driving the same car. You think, wow, this must be a really popular model. But actually, those cars were always there. You just didn't notice them before because they weren't relevant to you. Now that you own one, your brain highlights every matching car and filters out the others. This is called the frequency illusion, and it's harmless with cars. But it affects everything you think about. Or here's another one. You read a horoscope. It says you're going to have challenges with communication this week. And guess what? During the week, you notice every miscommunication, every time someone doesn't understand you, every awkward conversation, and you think, wow, that horoscope was right. But you don't notice all the conversations that went perfectly. You don't count the times when communication was easy. Your brain selectively remembers the hits and forgets the misses. This is how psychics work. By the way, they make vague predictions that could apply to anyone, and your brain does all the work of making them seem specific and accurate. You fool yourself into thinking they have special powers. Here's another example, a more serious one. You have a friend and you notice that your friend has been acting cold lately, not calling as much, making excuses not to see you. So, you think, sighs, she must be upset with me about something. And once you think that, you start noticing more evidence. Remember that time she seemed short with you on the phone. Remember when she didn't laugh at your joke. It all fits together. But does it? Or are you just filtering the world through your theory? Maybe she's been stressed at work. Maybe she's going through something that has nothing to do with you. Maybe you're noticing the time she seems cold and ignoring all the time she was warm and friendly. You don't know, but you